Well, here we are. It is now about 3 a.m. And I am just now starting to film here, and I hope to get done by 8 with all that I want to get done. There's probably about 30, 35 videos to film between now and then edit and then put it all together. But let's get started. This is the 2022 AMC 10A problem 1. It was also the 12A of the same problem. What is the value of? Okay, this should be something that you're kind of quick at, right? When you have 1 over A over B, that's simply the reciprocal of the denominator. So you're going to have 9/3 plus 1/3 is 10/3. That's now 3/10. Then you're going to have 30/10 plus 3/10 is 30. This 3 right here becomes 30/10. 30/10 plus 3/10 is 33/10, but you're flipping it. So it's 10 over 33. As you're writing it, change the 3 to 99 over 33, 109 over 33D. Let's get to the next problem. And that will bring us to the AMC 10A problem 3 from 2022, also the 12A problem 2. The sum of 3 numbers is 96. So we could say something like A plus B plus C is 96. The first number is 6 times the third, but then it's going to put the third in terms of the second. So we're going to call it B plus. The third number is 40 less than the second, so it'll be B minus 40. And then the first number, A, would be 6 times the third number. So you're going to get 6B minus 240. So then that's 6 times this, if you will, and this is going to equal 96. Now, what does it ask for? What is the absolute value of the difference between the first and second numbers? So you're going to want 6B minus 240 minus B, because these are the first 2 numbers. So if I do 6B minus B, we want the absolute value of 5B minus 240. Most likely that's going to switch because the 240 is probably, we'll just see what we get actually. So here we go. We've got 6B plus B is 7B plus 8B. 8B minus 240 minus another 40 equals 96. I'm not even going to bother to combine them, which is what I did on my paper as well, meaning I took it for myself, not officially or anything like that. So then I would just divide by 8 right now. So you'll get B minus 30 minus 5 equals 12. Take the 35 over there to get B is 47. 5 times 47 is 235 minus 240, negative 5, but absolute value. Get E, win a prize. Let's go to the next problem. And we are filming 2022 AMC 12A, problem 3. 5 rectangles, A, B, C, D, and E are arranged in a square as shown below. These rectangles have dimensions 1 by 6, 2 by 4, 5 by 6, 2 by 7, and 2 by 3, respectively. The figure is not drawn to scale. Which of the 5 rectangles is the shaded one in the middle? For me, I suspected there was going to be some certain kind of action going on, meaning that I probably just need to add up all the dimensions and find the ones that sum to a square. Like if I added up, if it had it has to be divisible by 4 basically. And so I just tried stuff out. I was like, okay, what if this looked like it was skinnier, so I put 1 and 6. And then maybe we could call this 2 and 4. And then the next one would be something like, we got 5 and 6. Maybe I could do 2 and 7 here. And then 5 and 6, I could put 5 here and 6 here, because see, now I've got 8 and 8 and 8. The problem is 5 and 4 is 9. And this is actually what I did when I solved it. I just threw them on to see what it would look like to confirm my suspicions that I could just add up all the dimensions. Now, you could still do that, but it should be pretty clear that this 4 needs to be a 3. And if I made it a 3, there is a 2 by 3 as well. And so that would give you exactly what you want. And that means the one in the middle must be the 2 by 4. And that's A and B. And this one's B. And the answer's B. Let's get to problem 4. Let's continue on. This is going to be the 2022 AMC 10A problem 7. It was also the 12A problem 4. The least common multiple of a positive integer n and 18 is 180. So a common shorthand notation is brackets for LCM. We want that to equal 180. And the greatest common divisor of n and 45, again, a common notation is parentheses, is 15. So this is just used in the AOPS books a lot. I picked it up from there. It's useful. What is the sum of the digits of n? So basically find n and then add up its digits. There's two ways you can approach this. One's going to be more formal, technical, definitive, and one's going to be kind of logic. The logical one would look something like this. If their greatest common divisor is 15, okay, so I'll put this here for your help, then that means n's got to be a multiple of 15, right? And so if you try 15 and then do it with 18, 15 and 18 will not have the 180. And then if you try 30 and then you go through like that, right? You could make n 45 and so on. You could just guess it out until you find one that also works in here and then go, using multiples of 15. So here's the more formal way you'd probably be doing it and feel, I don't know, a little bit more like you're doing it like you're supposed to. So for the least, I have a saying, for the least you want the greatest, and for the greatest you want the least. What does that mean? Well, 18 is 3 squared times 2. And we don't know what n is, but we know that for the least, you would want the greatest, and 18 over here times 2 times 5 is going to be 3 squared, 2 squared times 3 squared, I'll put it in reverse order like I did the other one, times 5. And just to verify, 36 times 5 is 180. So then, if for the least you want the greatest, what that means, oh, that's n, oops, wrong spot. Supposed to put it here, 3 squared times 2 squared times 5. What that means for the least you want the greatest is for the least common multiple, you want the greatest power you can choose, okay? So if I've got 3 squared, n does, at least in this case, it does not have to have any 3's. But if it did, they would not go over 2. What it does have to have is 2 squared, because this one's only got 1, 2. That's not the greatest because there's a 2 squared in the greatest. So this one must have a 2 squared. It can also not have 2 to the third, because if it had 2 to the third, that would be the greatest, and you would see a 2 to the third in here. Okay, there's no 5 in 18, so n's going to have to contribute that 5 as well. And then after that, we know the only other values we could have would be potentially 3 to some power. Okay, so far we have got 20, and then, yeah, times 3 to some power, maybe 0, could just be that. So then you're going to have that. Now, when we do the greatest common divisor, I say for the greatest, you want the least power available. And since 15 is 3 to the first times 5 to the first, but we're doing it with 45 now, so if I check 45, it is equal to 3 squared times 5 to the first. Well, if 3 to the first is the least power available, n's going to have a 3 to the first in it, because the 45 that it's working with has 3 squared. So that means we've got to have a 3 to the first, which is the least power between 3 to the first and 3 to the second. Okay, so then what? That means we've got here, the 5 to the first was already in n, and it's in 45, so no issues there. Everything looks good. Let's just make sure that this, and again, this could have been any power of 3 up until 2 for it to work with the LCM. And this is going to be it. N is this number. 4 times 5 is 20 times 3 is 60. Add 6 plus 0 to get 6. Let's get on to the next problem. Okay, so the final one of the first set for AMC 12, 1 to 5 rapid fire. This is my approach to this problem. Maybe you found a faster way. It's just the way I processed it. The taxi cab distance between points x1, y1, and x2, y2 in the coordinate plane is given by the absolute value of the difference in x plus the absolute value in difference in y. If you don't understand what's happening there, it's kind of like city blocks. The taxi cab can't go through. It's got to go only on the lines of the grid. For how many points P with integer coordinates is the taxi cab distance between P and the origin? So one of your 2 points is 0, 0, kind of nice, less than or equal to 20. Well, you can think about it this way. You could be over here at 20, 0. You could also be up to 0, 20, and you could go to negative 20, 0, and 0, negative 20. And if you count all of the ones on the x-axis, there would be 20 minus negative 20 plus 1 for the origin. And so you're going to get 41 points there. But when you go down this way, you don't count the origin, so you're only going to get 40 points there. So on your quadrantal values, on the axes themselves, you do get 81. From here, what we're looking for is for the sum of our x and y coordinates to be less than or equal to 20, but we don't want to include 0. And the reason is we've already got all those in that calculation. And maybe there's a faster way than this, like I said, but this is just the way I thought of it. So the xy, if x is 1, y could be 19, right, all the way down. Let's just do it the other way, actually. If x is 19, y could only be 1 or 0. So you're going to get one case there when x is 19. We'll go into the plus minus stuff later. So 18, if x is 18, now y could be 1 or 2, so you get 2 values. At 17, you get 1 or 2 or 3, so you get 3 values. And this will go all the way down until x is 1, and then y can be everything from 1 to 19. Again, we don't include 0 because I've already done it in my version, and you're going to get 19 here. So it looks like you're adding up the numbers from 1 to 19, but now we've got to accommodate the quadrants, and all the quadrants are the same. There's going to be a positive positive quadrant, a positive negative, a negative positive, and a negative negative. So I'm going to get 4 times the sum of the numbers from 1 to n is n times n plus 1 over 2. So it would be 19 times 19 plus 1 over 2. I'll put that into here to get 10, 7, 60, and 10. Or 76 and 10 is 760. And then I'm going to add 81, and that will put you at C, 841. Let's get to the next set of 5.